Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the practice questions on geometric progressions. If you need any extra help on geometric progressions, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 375, there's a dedicated video tutorial there on geometric progressions. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one says, here are the first 5 terms of a sequence. So we've got 1, 4, 16, 64 and 256. That's a calculator question, which is quite nice. And part A says write down the next term in the sequence, or work out the next term in the sequence. So it's a geometric progression, so we need to find out what we're multiplying by each time. So we're multiplying by 4, multiplying by 4, because obviously 1 times 4 is 4, 4 times 4 is 16, times 4 is 64, times 4 would be equal to 256, so we just need to multiply by 4 again. So if we get our calculator and multiply by 4, we'll get our answer. And that's equal to 1024. So the next term in the sequence would be 1024. And then part B says explain how we work that out, so let's just explain that. And that's it, just explain that each time we multiply by 4, so we worked out 256 times 4, and that's it. Okay, let's look at our next question, question number 2. Okay, question number 2 says the first 2 terms of a geometric progression are 5 and 15, and to work out the next term. Okay, so to find out what we're multiplying by each time, or the common ratio, what we can do is we can divide the second term by the first term. So if we do 15 divided by 5, that's equal to 3. So each time we're multiplying by 3, we've got 5, we're multiplying by 3, and that gives us 15. If we multiply by 3 again, that'll give us the next term in the geometric progression. And 15 times 3 is equal to 45. So the next term would be 45. And that's it. Okay, let's look at our next question, question number 3. So question number 3 says a geometric progression begins 2, 10, and so on. And we've been asked to work out the next 3 terms. So a bit similar to the last question, but this time rather than just find the next term, we want to find the next 3 terms. So let's start by taking our 10 and dividing it by 2. So if we do 10 divided by 2, that's equal to 5. So each time we're multiplying by 5. So if we start off with 2, if we times that by 5, we get 10. If we times that by 5, we get that's equal to 50. If we times that by 5, we get that's equal to 250. And then we just need to multiply that by 5. So we've got 50 is our next term. Then we've got 250. That's our next 2 terms. We want 3 terms. So we're going to need to multiply by 5 again. So I'm going to take, and it's a non-calculator question. So I'm going to take 250 and I'm going to multiply that by 5. 5 times 0 is 0. 5 times 5 is 25, so let's put a 5 down and carry out 2. 5 times 2 is equal to 10, plus 2 is equal to 12. So that'd be 1250. And that's it. So they would be the next 3 terms in the sequence. The sequence goes 2, 10, 50, 250, 1250, because each time we're multiplying by 5. Okay, let's look at our next question, question number 4. Okay, let's have a look at our next question, question number 4. So question number 4, we've got these 4 lists of numbers, and we've been asked to write down which of the following is a geometric progression, and we've been asked to circle the correct answer. So we're looking for geometric progressions. That's one where we're multiplying by the same number each time. So here, let's have a look at the first one. So 5, 8, 11, 14. Adding 3, adding 3, adding 3. So it's not that one. That's just an arithmetic progression. We're just adding the same amount each time. Okay, the next one. Well, the next one actually, 5 plus 6 is equal to 11. 6 plus 11 is equal to 17. That's a Fibonacci style sequence, so it's not that one. 5, 10, 20, 40. So we're multiplying by 2. We're multiplying by 2. We're multiplying by 2. So that is a geometric progression. So that is a geometric progression. So I'm going to circle that one because that's a geometric progression. We're multiplying by 2 each time. And then our next one, we've got 5, 7, 11, 17. It looks like a quadratic sequence where we're adding 2, then adding 4, then adding 6. So then the second differences would all be the same. So it's not that one. And that's it. So this one here is the geometric progression because we're multiplying by 2 each time. Okay, let's look at our next question, question number 5. So again, we've been asked to circle the geometric progression. So which one are we multiplying by the same number each time? So 2, 4, 6, 8, we're adding 2 each time. So that's an arithmetic progression. We're adding 2 each time. Okay, next one. Our next one is 2, 3, 5, 8. Now, it's not that one because we're not multiplying by the same number each time. I thought initially it was a Fibonacci style sequence because 2 plus 3 is equal to 5. 3 plus 5 is equal to 8. Or then I thought perhaps it was in a quadratic sequence because we're adding 1, adding 2, adding 3. So then the second differences would be the same. So I'm not quite sure which one that is, but it's not a geometric progression. Okay, the next one, 2, 4, 6, 10. So this one, where 2 plus 4 is equal to 6. 4 plus 6 is equal to 10. So it's not that one. We're not multiplying by the same number each time. Let's have a look at this one. 2 times 2 is equal to 4. Times 2 is equal to 8. Times 2 is equal to 16, and so on. So it's that one. That's the geometric progression. Okay, let's look at our next question, question number 6. Okay, so question number 6, we've got the second term and the third term of a geometric progression as shown below. So we've got this geometric progression and we've got the second term and the third term. And we've been asked to work out the first term and the fourth term. So we want to find this term and this term. So let's find out what we're multiplying by each time. So if we do 8 divided by 2, so 8 divided by 2 is equal to 4. So if we times by 4 each time, we're multiplying by 4. We're doing 2 times 4 is equal to 8. If we then times by 4 again, we can find the fourth term. 8 times 4 is equal to 32. So the fourth term is 32. And then this number times 4 is equal to 2. Or you could work backwards, you could divide by 4, because if we divide by 4, we can find the previous term. So if we take our 2 and we divide it by 4, 2 divided by 4, so half of it is 1, and half again is 0.5. So that means the first term is 0.5. And let's just check that. 0.5 times 4 is equal to 2. So that's it, so 0.5. And that's it. So the first term is equal to 0.5, and the fourth term is equal to 32. And each time we're multiplying by 4. And that's it. Okay, let's look at our next question, question number 7. So question number 7, we've got the first two terms of a geometric progression, so we've got 60 and 12. I've been asked to work out the third term of the progression, so we want to find our next number. Now, one approach that students use is to actually look at this and say, well, instead of multiplying each time, we can divide each time. So to get from 60 to 12, we would divide by 5, so we could divide by 5 again. And if you do 12 divided by 5, you could get this next number, because we're just dividing by 5 each time. Or another way to look at it is if you divide the second term by the first term, so if you do 12 divided by 60, and cancel that fraction down, you get that's equal to a fifth. So that means that we're multiplying by a fifth each time, multiplying by a fifth, multiplying by a fifth, and so on. So we're multiplying by a fifth each time. So even though the numbers are getting smaller, you're just multiplying by a fraction, such as a fifth or a half or a third, and so on. So in this case, we're multiplying by a fifth each time. So if we take our 12 and we multiply that by a fifth, so multiply by a fifth, that's equal to 12 fifths. And then 12 fifths, we could write that as a mixed number if we wanted to. How many 5s go into 12? That's 2. And then the remainder is 2, so that's 2 and 2 fifths, or 2.4. So you could write it any way you want. So we could write our answer as 12 fifths, or even 2.4, or 2 and 2 fifths, and so on. So that's our answer. So in this case, we're multiplying by a fifth each time. Now, some students might look at this and just say, well, we're dividing by 5 each time. And they'd say, well, 60 divided by 5, so divided by 5 is equal to 12. And we could divide by 5 again. And if we take our 12 and we divide that by 5, and I'm just going to use the bush shelter method and put a 0 because I know it's going to be a decimal number. How many 5s go into 1? 0, remainder 1. How many 5s go into 12? That's 2, remainder 2. And how many 5s go into 20? That's 4. So that's 2.4. So you can do it either way. You could either think, well, I'm multiplying by a fifth each time. Or you could just think, and I probably would do this, just look at it and say, well, we're dividing by 5 each time, so the next number would be 2.4. You could divide by 5 and divide by 5 and so on. Okay, let's look at our next question, question number 8. So question number 8 is a calculator question, and we've been asked to find the next term of the geometric progression. So we've got 4 fifths, 12 35ths, and 36 245ths. So what I'm going to do is I'm going to divide the second term by the first term to find out what we're multiplying by each time. If we do 12 35ths and we divide that by 4 fifths, that'll tell us what we're multiplying by each time. So let's get our calculator and work that out. I get that's equal to 3 sevenths. So that's equal to 3 sevenths. So that means that each time we're multiplying by 3 sevenths. And let's just check that. If we get our 4 fifths and we multiply that by 3 sevenths on my calculator, that's equal to 12 35ths. And then if we multiply this by, if we multiply 12 35ths by 3 sevenths, we get that's equal to 36 over 235. And now we're just going to multiply by 3 sevenths again. So on my calculator, I'm going to type 36 over 245 multiplied by 3 sevenths, and that's equal to 108 over 1,715. So the answer, the fourth term of the progression would be 108 over 1,715. And that's it. Okay, let's look at our next question, question number 9. Okay, so question number 9, we've been told the first term and the third term of a geometric progression, and then we're told that all terms in the progression are positive, and that's quite important, actually. And we've been asked to work out the fourth term in the progression, so we want to find this term here. So if we multiply 3 by a particular number, let's just call it y, so we multiply by y, and then multiply by y again, we would get that's equal to 48. So that actually means we can actually write an equation here, because if we had 3, and we multiply that by y, so times by y, that'll be equal to 3y. And then if you multiply by y again, well, y times y is y squared, so that'll be 3y squared. But I know this term, this third term, 3y squared, is equal to 48. So that actually gives us an equation that 3y squared is equal to 48. Now if we solve this equation, we can find out what y is, what we're multiplying by each time. And then once we find out what that is, we can then find the fourth term. So let's divide both sides of the equation by 3. So divide by 3 and divide by 3. And we would get that y squared is equal to, and 48 divided by 3 is equal to 16. So that means that this number squared is 16. Now that's actually quite useful because if we solve this equation, that y would be equal to either 4 or minus 4, we would actually get plus or minus 4 because it could be 4 squared is 16 or minus 4 squared is 16. But if y was equal to minus 4, 3 times minus 4 would be minus 12, and then times by minus 4 would be 48. But we're told that all terms are positive, so y can't actually be equal to minus 4. Y would have to be equal to 4 in this case. It can't be equal to minus 4, because 3 times 4 would be equal to 12, times 4 would be equal to 48, and then if we times by 4, we'd actually get this next term in the progression, the one we're trying to find. And it couldn't be equal to minus 4, because if you times by minus 4, you'd get that's equal to minus 12, and then 48, and so on. So that's why I said it was quite important that they told us that that term was positive, because we'd have two possible answers here rather than just one. So let's find this fourth term. So we need to multiply by 4. So we need to do 48 multiplied by 4. 4 times 8 is equal to 32. Put a 2 down, carry a 3. 4 times 4 is 16, plus 3 is equal to 19, so it's 192. So it's 192. So that's it. The fourth term in the progression is 192. And that's it. Okay, so question number 10. So question number 10 is a calculator question. We're told the second term and the fourth term in the geometric progression are shown. So we've got the second term and the fourth term. We're told all the terms are negative. And we've been asked to work out the first term of the progression. So it's a bit similar to the last question. We've got this number, minus 2 is the second term, and we've got the fourth term. So we don't have two consecutive terms, but we can times by y to get this term, and then times by y again to get this term. So that means that negative 2 times y, well, times y would be equal to minus 2y, and then times by y again will be equal to minus 2y squared. And minus 2y squared would be equal to negative 18. So that's an equation we can form, because minus 2 times y is minus 2y, times by y again would be minus 2y squared, and that's equal to minus 18. So that's an equation we can form. Minus 2y squared is equal to minus 18. Now in terms of solve this equation, the first thing I'm going to do is I'm going to multiply both sides of this equation by negative 1. So I'm going to times the left hand side by negative 1, and if you times this by negative 1, you're going to get that's equal to 2y squared. And then if it times the right hand side by negative 1, that gives us 18. So just multiply both sides of the equation by negative 1. Now you don't actually have to do that. You could just divide both sides by negative 2 to begin with, but I just tend to like doing that. I'm now going to divide both sides by 2 and divide both sides by 2 to get that y squared is equal to 9. And that means that y is equal to, what's going to be equal to, if y squared is equal to 9, that means that y is equal to plus or minus 3. Because the square root of 9 is 3, so it means that y could be equal to 3 or negative 3, because 3 squared is 9 and negative 3 squared is 9. So that means both y is equal to 3 or negative 3. Now it can't be equal to negative 3, because if we had negative 2 and we multiply that by negative 3, that's going to give us 6, but we're told that all terms are negative, so it means that y would have to be equal to 3 here. So we'll go times them by 3, times them by 3, times them by 3, and so on. So we've got our first term, we've got negative 2, we've then got our next term, and then we've got negative 18. So if we multiply by 3, negative 2 times 3 would be negative 6, and then times by 3 again would be negative 18. So that's great, that works. Now we're asked to work out the first term of the progression, so let's divide by 3 to go backwards. So let's take our negative 2 and divide it by 3. So if we do negative 2 divided by 3, that's going to be equal to negative 2/3. So this term would be negative 2/3. And let's just check that. If you had negative 2/3, you times it by 3, well, that would get rid of the 3 in the denominator, so you get negative 2. So that's it. So it would be negative 2/3. Actually, it's a calculator question, so you could just take your negative 2 and divide it by 3 in your calculator, and that gives you negative 2/3. Always read the question. Okay, question number 11. So question number 11, we're told the first two terms of a geometric progression are 3 and 12. So 3 and 12. They're the first two terms of a geometric progression. And we've been asked to find the sum of the first 5 terms. So we've got the first term, the second term. Let's find out what we're multiplying by each term. So to get from 3 to 12, 12 divided by 3 is equal to 4. So we're multiplying by 4 each time. So 12 times 4 will be equal to 48. So times them by 4. Times them by 4 again will be equal to 192. And times them by 4 again will be equal to 768. And we want to find the sum of the first 5 terms. We just need to add them together. So if we add those together in our calculator, that'll be our answer. So if we do 768 plus 192 plus 48 plus 12 plus 3, that's equal to 1023. So that means the sum of the first 5 terms would be 1023. And that's it. Okay, let's look at our next question, question number 12. So question number 12, we're told the fifth term of a geometric sequence is 3072 and the sixth term is 24,576. And we've been asked to find the first term. It's a calculator question, so that's great. And these are consecutive terms. We've got the first term, what we're trying to find, the second term, the third term, the fourth term, the fifth term, 3072, the sixth term, 24,576. Okay, so let's find out what we're multiplying by each time. So what do we multiply by? So if we get our calculator and we do 24,576 and we divide that by 3,072, so that's going to be equal to 8. So each time we're multiplying by 8. So if we want to go backwards, we can divide by 8. We can just divide by 8, divide by 8, divide by 8, and divide by 8, and we'll get the first term. So if we divide by 8, so let's divide by 8, 3,072 divided by 8 is equal to 384. If we then divide by 8 again, that's equal to 48. So dividing by 8 again. Dividing by 8 again, dividing by 8 again will be equal to 6. And dividing by 8 again will be equal to 0.75 or 3/4. So the first term is 3/4. So that's it. So 3/4 or 0.75. Okay, let's look at our next question, question number 13. Okay, so question number 13 says the ninth term of a geometric progression is double the 10th term. So the ninth term is double the 10th term. That's interesting actually, because if you think about it, if you were to have the 1, 2, 3, 4, 5, 6, 7, 8, and then ninth this term, the ninth term, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 10th term, the 10th one. The ninth term is double this one, so this time it's getting smaller, so we're multiplying, because it's double, that means we're multiplying by half. You're multiplying by half each time, we're multiplying by half. Multiplying by half, because this number times a half is equal to that number. Some students might think of it in terms of dividing by 2. We're dividing by 2 each time. We're just dividing by 2. We're dividing by 2, and so on. So it says that the first term in the geometric progression is equal to 300. So we know the first term is 300. We want to find the third term. So we want to find this term here, the third term. So because we know we're multiplying by half, we're dividing by 2. We can just divide by 2. That's going to be 150. And divide by 2 again, that's 75. So that means the third term is equal to 75. So the third term of the progression would be equal to, the third term is equal to 75. And that's it. Okay, so question number 14, we're told that A is an arithmetic progression and the nth term of A is 9n minus 3. So that's the nth term, 9n minus 3. And B is a geometric progression and the first three terms are 3, 6, 12 and so on. And then we're told the 43rd term of A, the 43rd term of this sequence here, is equal to the xth term of this one here. And we've been asked to find out which term. So let's find what the 43rd term of A is. So in terms of A, we've got the nth term, which is 9n minus 3. So if we want to find the 43rd term, we just need to do 9 times 43 minus 3. And it's a calculator question. So we can just do 9 multiplied by 43 and then take away 3. And that's equal to 384. So that means that the 43rd term of this sequence is equal to 384. Remember, to find the first term, we substitute in 1. To find the second term, we substitute in 2. So if we want to find the 43rd term, we substitute in 43. 9 times 43, take away 3 is 384. Now we want to find out which term in the sequence it is in B. So in terms of B, we've got 3, 6, 12. Each time we're doubling, we're multiplying by 2. So multiply by 2, multiply by 2. And let's carry on and find where 384 is. So if we multiply by 2, we're going to get that's equal to 24. If we multiply by 2, now you might think this is going to take lots and lots of time, but we are doubling, so it's going to get quite big quite quickly, so don't worry. If we multiply by 2, that's equal to 48. It's a calculator question, so 48 times by 2 is equal to 96. So times by 2 is equal to 96. And then answer times 2, press equals, times in 2 would be equal to 192. Times by 2 again will be equal to 384. So that's the 1, 2, 3, 4, 5, 6, 7, 8th. It's the 8th term. It's the 8th term of B. So find x. X is 8. It's the 8th term. And that's it. So it's the 8th term. Okay, let's have a look at our next question, question number 15. So question number 15 says the second term of a geometric progression is 48, the sixth term is 12,288, and we're told all the terms in the progression are positive. Find the fifth term. Okay, so we've got the first term. Well, we don't know that. We know the second term is 48, then there's the third term, the fourth term, the fifth term, and then the sixth term is 12,288. And we want to find this term here. Okay, so because this is geometric progression, we're multiplying by the same number each time. So we're multiplying by a number. So it could be perhaps y. So multiplying by y, we then multiply by y. So we multiply the second term by y, that'll give us the third term. We multiply the third term by y, that'll give us the fourth term. If we multiply that by y, we'll get the fifth term. And if we multiply that by y, we'll get the sixth term. So that means if we take our 48 and we multiply it by the same number 1, 2, 3, 4 times, we would get 12,288. Now actually let's form an equation here, because 48 multiplied by y, multiplied by y, multiplied by y, multiplied by y, that'll be y to the power 4, would be equal to 12,288. And this is an equation we can solve. We can divide both sides by 48. So if we divide by 48 and divide by 48, we get that y to the power 4 is equal to 256. And then we want to find out what y is, so we're going to take the fourth root of 256. So y is equal to plus or minus the fourth root of 256, which means that y is equal to plus or minus 4, because 4 to the power 4 is 256, or negative 4 to the power 4 is 256. So that means that we're either multiplying by 4 or negative 4. Now, because all terms in the sequence are positive, it can't be negative 4, because that would make this term negative, this one positive, this one negative, this one positive. It says all terms are positive, so that means that it has to be 4. So y is equal to 4. Now we want to find the fifth term, so we want to find this term here. So we could take our 48 and times it by 4, times it by 4, and times it by 4 again to get this number. Or you could just work backwards, you could just divide by 4. So let's take our 12,288 and divide by 4 and see what we get. So 12,288 divided by 4 is equal to 3,072. So that means the fifth term is 3,072, and that's it. And that's it. Okay, let's look at our next question, question number 16. Okay, so question number 16, we've got some surds here. It's a non-calculator question. And we're told here the first four terms of a sequence, 2, 2 root 7, 14, 14 root 7. And we've been asked to find the fifth term of the sequence. So let's find out what we're multiplying by each time. So we want to find the next term here. So to find this next term, let's see what we're multiplying by. So to find what we're multiplying by, we can just divide a term by the previous term. So if we take our 2 root 7, so 2 root 7, and we divide that by 2, we can see what we're multiplying by. And 2 root 7 divided by 2 would just be root 7. So we're multiplying by root 7 each time, because if you take 2 and you multiply that by root 7, you'd get 2 root 7. If you multiply that by root 7, well, root 7 times root 7 is 7, and then you're multiplying by 2, so that'll be 14, because 2 times 7 is 14. Then if you multiply by root 7 again, you'd get 14 root 7, and so on. So we're multiplying by root 7 each time. And the question says find the fifth term of the sequence. We want to find this next term, this fifth term. So we want to multiply by root 7 again, because every single time we're multiplying by root 7. So we need to do 14 root 7 multiply by root 7, and then that'll give us our answer. So let's work this out. Well, we've got root 7 times root 7, and root 7 times root 7 is 7, so that means you would have 14 times 7, so that'll be 14 times 7, and if we work out what 14 times 7 is, that's our answer, because root 7 times root 7 is 7, and then you got 14 times 7, and 14 times 7 would be equal to, 10 times 7 is equal to 70, and 4 times 7 is 28, so that'll be 98. So that's it, so the next term in the sequence, the fifth term, is 98, and that's it. Okay, let's have a look at our next question, question number 17. So question number 17 is a similar question where we've got some surds and we've got the first three terms of a sequence, 6 root 3, 18, 18 root 3, and we want to find the fourth term in the sequence. So let's find out what we're multiplying by each time. So here, if we would divide a term by the previous term, we can find the common ratio of what we're multiplying by each time. Now I could do 18 divided by 6 root 3, but I actually think it's going to be easier if I divide the third term by the second term. So I'm going to take the 18 root 3 and divide that by 18. It's just a bit easier than doing 18 divided by 6 root 3. 18 root 3 divided by 18 would just be root 3. So that means we're multiplying by root 3 each time. We're multiplying by root 3. We're multiplying by root 3. And let's just check that. If we had 6 root 3 multiplied by root 3 times root 3 is 3, and then 6 times 3 is 18, so that would work. Okay, so we're multiplying by root 3 each time. We want to find the fourth term, so we want to find this next term, so we're just going to times by root 3. So we've got 18 root 3, we're going to multiply that by root 3. So root 3 times root 3 is 3, and then we're going to times that by 18. So 18 times 3, and that'll be our answer. So 18 times 3, well 3 times 10 is 30, and 8 times 3 is 24. Add them together would be 54. So that means that this term is 54. And that's it. We've found the fourth term in the sequence, 54. Okay, let's look at our next question, question number 18. Okay, so question number 18, again we've got some surds, and we've been asked to find the next term in the sequence. Okay, so we've got root 3, we've got 6, we've got 12 root 3, and then we've got 72. So again, what I'm going to do is I'm going to divide a term by the previous term, and I could do 6 divided by root 3, but I think it'd be much easier to do 12 root 3 divided by 6. I just want to divide by that whole number. So I'm going to divide the third term by the second term. So 12 root 3 divided by 6. And if I had 12 lots of root 3 and I divide that by 6, I would have 2 lots of root 3, just dividing the number in front of the third by 6. So 12 divided by 6 is 2, so it'll be 2 root 3. So multiplying by 2 root 3, we're multiplying by 2 root 3 each time. Multiply by 2 root 3, multiply by 2 root 3. And let's just check that. Root 3 times 2 root 3. Well, root 3 times root 3 is 3, times 2 would be 6. 6 times 2 root 3 would be 12 root 3. And then 12 root 3 times 2 root 3. Well, 12 times 2 is 24. And root 3 times root 3 is 3. And 24 times 3 would be 72. So yeah, that all works. So we want to find the next term. So we need to multiply by 2 root 3. So 72 times 2 root 3. Well, 72 doubled would be 144. So it's going to be 144 root 3. So the answer would be 144 root 3. And that's it. Okay, let's look at our next question, question number 19. Okay, let's have a look at our next question, question number 19. So question number 19, I really like these questions, and it's where we've got a geometric sequence or progression and where we've got algebraic terms rather than numbers. And here we've got the first 3 terms of this geometric sequence are x minus 15, x, and 3x plus 20, where x is positive. And we've been asked to find the value of x. Okay, so with a question like this, what I'm going to do is I'm going to go back to one of our geometric progressions whenever we've got numbers. So we've got 1, 4, 16, 64, and 256. And if you divide a number by the previous number, you'll get what you're multiplying by, or the common ratio. So 4 divided by 1 is equal to 4. 16 divided by 4 is equal to 4. 64 divided by 16 is equal to 4, and so on. So if you divide a term by the previous term, you'll always get the same number. And thinking about what a geometric progression or sequence is, that makes sense because we're multiplying by the same number each time. So if we go back here to our sequence here, if we divide a term by the previous term, we'll get what we're multiplying by. So if we divide the second term by the first term, so the second term divided by the first term, that would be what we're multiplying by. And that would be the same as what we get if we divide the third term by the second term. Because if you divide the second term by the first term, that'll be what you're multiplying by. If you divide the third term by the second term, that'll be what you're multiplying by, and that'll be equal. So that means we can write an equation, we can form an equation that 3x plus 20 divided by x, the third term divided by the second term, will be the same as x divided by x minus 15. So that's our equation. And now we've got our equation, we just need to solve it. So one way we can solve this equation is to multiply both sides by x minus 15. So if we've done that, we would get on the left hand side, we're multiplying both sides by x minus 15. So we're multiplying by x minus 15 and multiplying by x minus 15. And on the left hand side, we're multiplying by x minus 15 to get rid of the x minus 15, so we'd just be left with x. And on the right hand side, we've got this fraction, we'll multiply it by x minus 15. So whenever you multiply a fraction by something like this, it would just go in the numerator. So you've got 3x plus 20 brackets, and then x minus 15 brackets, and that's all divided by x still. Now, we don't want this divided by x, so we're going to multiply both sides by x, so multiply by x and multiply by x. So on the left hand side, we would get x squared. And on the right hand side, this divide by x would go, so we'd just be left with, in brackets, 3x plus 20, and then in brackets, x minus 15. So what we've done is we've multiplied both sides of this equation by x minus 15, and we've multiplied both sides of the equation by x. Now there's a bit of a shortcut, and that is cross multiplication. And there's a video on Corbettmaths on cross multiplication. It's a really useful technique. If I had a fraction equals a fraction like this, I would just multiply this numerator by this denominator, that's x squared, and I'd multiply this numerator by that denominator, and that would be 3x plus 20 multiplied by x minus 15. So I could just go from here to here, and that's what I would do if I was doing this question. Okay, so we've now got this. Let's solve our equation. So let's expand our brackets. So we've got x squared on the left-hand side. 3x times x is 3x squared. 3x times minus 15 would be minus 45x. 20 times x would be plus 20x. And then 20 times minus 15 would be minus 300. Now let's simplify this. Our left-hand side would be x squared. On our right-hand side, we've got 3x squared. We've got minus 45 plus 20. That's going to be equal to minus 25x. And we've still got our minus 300. Okay, now let's get rid of this x squared. So let's minus x squared and minus x squared. So on the left hand side, we'd just be left with 0. On the right hand side, we'd have 2x squared minus 25x minus 300. Okay, now let's factorize this. So 0 equals bracket, 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 bracket. And hopefully this factorizes. I'm going to go for 2x and x. And I want two numbers that multiply together to be minus 300. And whenever I expand the brackets, I get my minus 25x in the middle. And I'm thinking if I put minus 20 there and 15 there, let's just see if that works. 15 times minus 20 is our minus 300. Fantastic. 2x times minus 20 would be minus 40x. And 15 times x is 15x. So if you go back up 15, that would be minus 25x. So that's it with factorizing. factorised it. So now let's solve this. So here, this one here, we'd have that 2x plus 15 is equal to 0. If we take away 15 from both sides, we get 2x equals minus 15. And divide by 2, we get x is equal to minus 7.5. And here, if we look at this, we would just get x is equal to 20, x is equal to 20 to make that bracket 0. Now, if we go back up, let's see if either of these will work. So we've got x is minus 7.5. So the second term in the sequence was x, so that would mean that that would be minus 7.5. But it says that x is positive, so it can't be that one. And then it says that x is positive, so that means that x is going to be 20. So this term is 20. And let's just check this. If we had 20 take away 15, that's going to be 5. Here, 3 times 20 is equal to 60, plus 20 is equal to 80. And let's just check. 5 times 4 is equal to 20, and 20 times 4 is equal to 80. So yeah, that works. So to find the value of x is 20, and that's it. So the value of x is 20, and that's it. Okay, let's have a look at one more question. Okay, so question number 20. So question number 20 is a similar question to 19. I just wanted to have another question there just in case you needed to watch that video for 19 and then you wanted to try 20 yourself and so on. So it's a geometric sequence. We've got these algebraic terms and we've been asked to find x. So this is the first term, x plus 18. This is the second term and this is the third term. So remember, with a geometric sequence, if you divide the consecutive terms, you'll get the common ratio, what you're multiplying by each time. So the second term divided by the first term would be equal to the third term divided by the second term. So we've got an equation. Now let's solve our equation. Now this time I'm going to use the cross multiplication. I talked about that in the last question, so go back and watch that if you want to. So this numerator times that denominator is equal to this numerator times that denominator. So x times x is x squared, and that would be equal to, and then in brackets, 2x minus 15, and then in brackets, x plus 18. So just multiplying that numerator by that denominator, that'll be the same as that numerator times that denominator. And if you want to, you can check that out with two fractions. Choose two equivalent fractions, so it's just a half and 25/50ths, and see if it works. Okay, so we want to solve this equation. So we've got x squared, and then let's expand our bracket. So we'd have 2x squared. We then have plus 36x, and then minus 15x, and then minus 270. Okay, so we've now got this. Let's solve this. Let's simplify this right-hand side. So we'd have x squared equals 2x squared, and then plus 21x minus 270. And then taking away x squared from both sides to give us 0 equals x squared plus 21x minus 270. And now we just need to factorize this. So put our brackets in, bracket, 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 bracket. So we want to factorize this. So we want two numbers. So let's put x's in the front of both brackets. And then we want to find two numbers that multiply together to be minus 270. So one's going to be plus and one's going to be negative. And then when we add them together, we get that's equal to 21. So that's going to be plus 30 and minus 9. Because 30 times minus 9 is minus 270. And minus 9 plus 30 is equal to 21. Okay, now we want to solve this equation. So that means that x is equal to here, minus 30. Or here, x is equal to 9. So we've got our two values of x. Now the question says that x is positive, so that solution is not going to work. And we just need to find x, so x is equal to 9. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on geometric progressions. I really hope you found this video useful. If you have found it useful, please like and please subscribe to the YouTube channel. Also, if you need any extra help on geometric progressions, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 375, there's a dedicated video tutorial there on geometric progressions. Alternatively, scan this QR code. But in this video, we focus on the video solutions to the practice questions. I really hoped it helped, and thanks very much. Cheers. Bye.